Hello everyone, welcome back to my channel Electrical Concepts. In this video lecture, we'll continue our discussion on stability analysis of practical circuit. In my previous video lecture, I have discussed about the RL series circuit and the DC transient, but this time it is RC series circuit. Okay, so let's start. So this is the circuit diagram of RC series circuit under DC excitation. Okay, so if you see the mathematical expression in detail, you will get this kind of expression. I have made a video on this about the DC transient analysis of different circuits. You can go through that video lecture. Okay, so there I have derived all these things. So if you perform the Laplace transform and then if you perform the inverse Laplace, you will get this kind of expression of the voltage across capacitor. Okay, this is the S domain expression and this is the time domain expression. And see, by looking at this response and this response, you can comment that the system is stable. See, the voltage is converging to a steady state value. Okay, similarly here, see, one pole is at the origin and one pole is at the left hand side. So these two indicate it is a stable system. Tc is the time constant, that means RC, R into C is the time constant of this circuit. So now suppose you want to keep the C constant and you want to vary the resistance. So automatically if you vary the resistance, it will vary the time constant and automatically it will affect the stability. See, stability is just the reciprocal of the time constant. So if you decrease your resistance, stability will improve. Why? Because if you decrease resistance, this term will go far away from this j omega axis, right? So if it goes far away from j omega axis, its stability gets improved, right? So now let's say if you keep on decreasing the resistance, what will happen? It will keep on going away from the j omega axis, and as a result what will happen? It will also change its response, because if you decrease the resistance, the time constant will also decrease. So in that case it will reach the steady state faster. That means its stability is getting improved. It also indirectly means the response will reach its steady state faster. So see what will happen. Resistance is decreasing. See, now it reaches the steady state faster, and also the pole is far away from the j omega axis, right? And if you again if you want to decrease, if you want to increase the resistance, in fact, what will happen? See, if you increase the resistance, again the system will be slower than the previous case. Why? Because now the pole has come closer to the j omega axis, that means stability is decreased. So this is how the RC parameters affect the time constant and also affects the stability of the system. Okay, I hope these things are clear to you. If you have liked this video, please comment, share, and also don't forget to subscribe to my channel. In my next video lecture, I will come up with such more interesting concepts. Till then, goodbye.